Before the first tunnel was driven, the Tsugaru Strait had to be understood from the surface.
Survey crews worked in cold seas, where wind and swell could end a measurement window within minutes. When the sea forced them back, the engineers changed the method, not the objective.
Back on land, every field note was compared against the proposed route. A physical model showed the narrow corridor connecting Honshu and Hokkaido. The alignment would descend beneath the seabed, protected by more than 100 meters of rock.
Construction depended on 3 linked excavations: the pilot, service, and main railway tunnels. Only after the route was locked could the full survey program begin.
Surveyors fixed the future portal position with optical instruments and permanent ground markers. Triangulation from separate stations carried the alignment across difficult coastal terrain. Boreholes tested the rock before underground excavation could begin.
At sea, crews waited for a narrow weather window to hold the vessel on station.
Seabed cores returned with direct evidence of the rock beneath the strait. Land and marine samples were combined into one geological model of the route.
A temporary access road brought workers, supplies, and equipment toward the future portal.
Convoys moved construction materials into the newly established work zone.
The hillside was stripped back until competent rock stood exposed.
Survey marks defined the first drilling pattern at the closed portal face. A controlled blast opened only a shallow recess into the mountain. Loose rock was removed, and the first steel support secured the entrance.
3 pneumatic drills began the first pilot tunnel excavation round.
Every hole had to match the planned depth and angle before explosives could be loaded.
One blast advanced the heading by only a short distance.
Ventilation cleared dust and gases before anyone returned to the face.
A compact loader removed the broken rock left by the blast.
Steel ribs and timber lagging stabilized weak sections immediately.
Ventilation, drainage, compressed air, and power followed the advancing face.
Cycle after cycle, the service tunnel became the project's underground lifeline.
Surveyors marked where connecting galleries would branch from the service tunnel. These short passages created access to the future main tunnel alignment. Every gallery had to meet the main tunnel center line at the correct elevation. The rock was widened into a starter chamber for the much larger railway tunnel. At the closed face, crews prepared the first main tunnel drilling pattern. The first main tunnel round required a much larger and denser drilling pattern. Explosives were loaded carefully across the face before every worker withdrew.
The controlled blast began opening the upper heading of the main tunnel. Ventilation and gas tests cleared the heading before mucking could begin.
The upper section was excavated first, leaving the lower bench intact. Temporary ribs stabilized the crown before excavation continued below. The rock surface was cleaned, patched, and prepared for waterproofing. Membrane and back drainage were installed in controlled sections. Reinforcement followed the horseshoe profile without puncturing the waterproof layer. A movable steel form carried concrete around the walls and crown. Surveyors marked 2 permanent railway center lines on the completed invert.
Built meter by meter beneath the sea, Seikan became a lasting monument to Japanese engineering.